Hello, today we're going to continue our forensic challenge by analyzing a compromised system. The last time I analyzed a clean configuration, so we had pretty much a baseline. This time we're going to see what artifacts and event IDs we can find when we exploit a Windows 7 system. So the first step is exploitation, and here I'm preparing a custom SF Venom payload. I'm choosing port 666 devilish attack, performing 50 or better 120 iterations in order to obfuscate our payload and produce a malicious executable that we're gonna call videoplayer.exe. Okay, bear with me for a second. Alright, there we go. Now we have our malicious payload. We simply need to move it to the web root directory so we can access it from the victim machine through the browser. And now let's start our Apache server for this reason. That's about it. The next step is to start Metasploit and use the custom exploit called multi-handler in order to pick up the reverse connection that we're going to receive from our victim machine. But before doing anything to our victim machine, let's change our audit policies in order to create an audit trail for our attack. Here I'm going to change and enable a series of local policies for us to have events in Windows logs that we can track and that might be able to tell us whether the attack was in progress and whether it was successful or not. I suggest you to have a look at the explanation as well. Very interesting. We only want to enable policies related to critical events, otherwise you're going to have a bunch of irrelevant logs that will only cause noise and waste of time for us. Okay, we're pretty much set for all concerning local policies here. So now we're good to go and we're ready to perform our attack. As now we have the chance to generate an audit trail that can track it. Let's now first download the executable in order to launch the attack. Here we have it. On the other end, in our Kali machine, we need to launch the exploit command, because now we completed our configuration for the exploit. It's all good to go. So let's run the executable. But first, let's launch the exploit command so we can start creating a session. And there you have it. We see information about our victim machine, which is a Windows 7 professional machine. The next step is to perform a privilege escalation on this machine. So we're going to use this exploit, very reliable. And in the nick of an eye, we're back in. This exploit got rid of user access control, and we could get a privilege escalation. Now with PS, we can see all the running processes in our victim machine, including those related to the system administrator, because we achieved the privilege escalation. In fact, we can now migrate to a higher priority process. And I can kill the executable I used to hack in. Now I need to find its process ID. You'll notice PowerShell. That's another process that could raise a red flag if you're not running a script. Anyway, I killed the process. And now if we get our current user ID, you notice we're the system administrator. So we can dump the password hashes. Let's now open a Windows shell. These are the accounts currently existing on the system. We can add a new account so we can achieve persistence, because we now gonna have the credentials to log normally in the system as an authorized user. So I'm going to add this user called Black Hat. Funny. Alright. If we now see the settings for this user, we notice it belongs to the user's local group. We want this user to belong to the administrators group though, so let's see which of these users in the systems belong to the administrators local group. Here I misspelled administrators. No big deal. Alright. you'll notice that Black Hat doesn't belong to this group, but we're system administrators, so we can do whatever we want. And in the nick of an eye, Black Hat now it's added to this group. In fact, if we see the members of the administrators group, now Black Hat is included. That pretty much concludes our exploitation from Kali. Let's now move to the victim machine in order to analyze what we can find and what artifacts are generated over malware attack from Kali Linux. So first and foremost, let's have a look at Event Viewer. We're mostly interested in the security and system log. Here you see a bunch of interesting events. You can filter the way Event Viewer displays the logs, but this tool is very cumbersome and anyways not really quick and easy. You gotta scroll through a bunch of logs, and even if you filter them, it's still too much information. Anyway, here you'll notice a series of interesting events. This is when, for example, we added Black Hat to the administrators local group. That's when we achieved the privilege escalation. This is another interesting event. That's when we changed the user account, adding it to the administrator group. And that's where we created Black Hat user. So you notice how every action we performed on Kali was logged on the victim machine, and we can retrieve an event ID for each one of them. Let's now dig a little deeper, having a look at the current processes running on our Windows machine. And let's go again. The command is netstat-abno. For more information about the netstat command, use netstat followed by a / and a question mark. Here I misspelled the command, no big deal, but I do it all the time, sadly. Okay, this time we're good to go. So let's have a look at our file here. This is the output file we created. And we want to have a look to the IP address for our Kali Linux attacking machine as we know it. And here we find 3 processes. 2 of them are running on port 666. And even though I killed the process video player.exe, it's still there. Another one is a system process I migrated to after hacking into the system. Let's now have a look at the processes included in svchost.exe, which starts most processes in Windows and can be used to disguise malicious processes. Nothing suspicious pops up here. Let's now run an important command wmic process list full. I redirected the output to a file here too, and let's look for interesting entries. These are all system processes, so nothing stands out in this case. So let's try to find something interesting amidst this mess. This was a previous executable I used, but it's no longer running in memory. And here we found the last malicious executable we used. Here we can have a series of interesting information about this. Okay, this is pretty much about it for this. We can also have a look at other runs to monitor other starting entries in Windows. There are much more than what you can find by scanning the registry or analyzing Task Manager Startup tab. But nothing pops up. There's a much better way for you to view event IDs from Event Viewer, and this PowerShell script allows to retrieve critical events from the system and security log and to display them in a CSV file, so we can have a neat spreadsheet that we can view in Excel, so we can filter it out or parse it by using PowerShell or other programming languages like Python, for example. So let's now run this PowerShell script. I post a link to the code on GitHub that I already published. The rest of the script worked just fine. In fact, we created two CSV files, one called security for the security log, and one called system for the system log. I don't have Microsoft Office on this virtual machine, so I'm gonna move these files to my physical macOS system so I can view them with Microsoft Office 2016 that I have on my Mac. Let's now have a look at the security log and see how neat that is. Very orderly, very neat. We have all the data we need in the spreadsheet, and we can filter them out or parse them through other programming languages. I think it's pretty awesome. You'll notice interesting events like 4674, which is privilege escalation, and so on and so forth. Now, once I expand the first column, you'll notice we have the same event description as an event viewer, but it's much easier to consult here. You have an immediate overview of all the events you need. You see a user account was changed, and so on and so forth. Very cool and useful in my opinion. Of course, you can have many more logs than these, considered you can have logs from multiple computers, for example. We didn't have any events matching the event IDs we entered in the script for the system log, but that's no big deal. Now let's look at how events look like in a CM solution, because I'm an analyst. I don't have the luxury of having event viewer logs normally at my disposal. I need to rely on server logs that are pushed to my system through Alien Vault. And this is what they mostly look like. Now, this is not very interesting. This event log is mostly referred to Office 365 users. I'm going to show you in my post a working example duly redacted in order to protect the privacy of my clients that resembles much more closely event viewer logs. You'll find it very interesting. Okay, that's all I got. I hope you enjoyed this video and the related post, and I think I'm gonna continue digging in the rabbit hole as I do every day at work, because that's part of my daily job. So I enjoy it a lot, and I hope so will you. So have a good one, guys. Bye bye.